Okay, so this is my third attempt at a video at lesson 9 of Unit 7. Um, just had a couple of hiccups, and sorry this is all messy. I looked at the key because I couldn't figure out this one. Well, I realized that they had a typo in here, so hopefully I reminded you guys to correct this before you attempted it. Um, but anyway, so they gave you this series of shapes, saying that it's part of mountain bike trails, and with all these different series of measurements, I made all the I tore the paper erasing it so much, but I made all the this is 23, but I made all the angles purple and all the line segments red. Right, so now we have to just solve for what they ask us to solve. All right, so HF is the hypotenuse of this larger triangle. Right, so in order to solve for the hypotenuse of the larger triangle, it's going to be the cosine. The cosine of 43 equals the adjacent 8 over hypotenuse, or we'll just say it's 8 over HF. Right, so it's going to be longer than 8, right? It's going to be longer than 8, so if you do the algebra, then you know that HF equals 8 divided by cosine of 43, right? And remember, any angle less than 90 degrees, the cosine is going to be, sine or cosine is going to be less than 1. And if you divide anything by less than 1, just make it greater than 1. It's going to make it bigger. So 8 divided by 43 cosine equals, that means that HF is 10 point, and it says round to the nearest tenth. So this is going to be 8.9 or 10.9. 10.9. Okay, HY. There's Y and there's H. Well, here's a 45, 45, 90 triangle. So that means that this is 4 times the square root of 2. Right, because we remember that the 45, 40, 45, 45, 90 thumb rules. It's a thumb rule, right? Because the hypotenuse is 4 times is the square root of 2 longer than the lengths, right? So it's 4 times the square root of 2. That's easy. All right, RD. Where's R? This is D. Okay, so let's see, RD. I'm gonna pause this for a second while I figure this one out. Well, because this is a right angle, and this is a right angle, and this is a right angle. Well, that means that this is a right angle because the quadrilateral is here. So this means this is a rectangle. So this is 4, this is 8. That means that this line here is 8 as well. So this is 8. Okay, so if that is 8, right, and then you can say that this is 23. So this again will be the cosine of 23. The cosine of 23. 23 equals 8 over, and we're looking for, are we looking for the RD? oh, I'm sorry, that's not going to be, we're going to look, that's going to be the tangent. The tangent, we're looking for opposite equals opposite, which is RD over adjacent, which is 8. Okay, so now we're going to put RD, therefore RD equals 8 times the tangent, 8 times the tangent of 23. Okay, so 23 tangent times 8 equals 3.4. Be equal to 3.4. That makes sense, right? Because this is longer than that. So this is the smaller angle of the two, right? And so that should be the smaller length of the two. All right, now we have to figure out what RM is. This is 3.4. 3.4 RM is a hypotenuse. We could use Pythagorean's theorem, but I don't want to. Let's do the cosine opposite over, well, let's do sine. I'm going to use sine yet. Opposite over hypotenuse. So the sine of 23, sine of 23, or we could do, yeah, let's do that, sine 23 equals opposite, which is 3.4, over Rm, which we're looking for. Therefore, Rm equals 3.4 divided by the sine of 23. All right, so I'll do that real quick. 3.4 divided by 23 sine equals, that's 8.7. 8.70. 8.7. 8.7. That one. Okay. All right, so that's that one. So Mario starts his ride at point W. All right, that's point W there. So this is 3.4 to 5. All right, so 3.4 to 5. So this is and he rides along the perimeter of W to Y, and from to H to G to F to R, and then back to W. So what is the length? All right, so this is 4 square root of 5, or 4 square root of 2. Right, and then so we got to figure out this length, which we know is 4. This is a right angle. This is a right angle. That's a right angle. This is 3.4. And so we got to figure out this length here. So how can we do that? We know that this is a proportional triangle here. So this is 3.4 to 5. Okay, so what's our proportionality? Little to big, 3.4 divided by 5. So we're little to big. Little to big is 3.4 to 5, which is fraction of decimal, 17 to 25ths. Okay, 17 25ths. Okay, so let's see here. That was R to M, right? Yeah, R to M. So our little triangle was 8.7. We're looking for the big side. All right, so now we got to solve. We got to solve that. right? So let's go ahead and solve that. All right, so 17x equals 8.7 times 25 equals 21 equals 217.5. Divide that by 17 equals 12.8. X equals 12.8. So that's the entirety of this length, right? But he's not bicycling this part. He's just bicycling this part. So we got to subtract 8.7 from that. So minus 8.7. So he's only doing 4.1. So WR is 4.1. Right? So 4.1 WR equals 4.1. All right, cool. Now we just got to figure out RF. Okay, so we got this triangle here to figure out RF. So this is 43. What size do we have? Okay, well we have 3.4, and we have, so this is 7.4. This length here is 7.4. That's cool. Do we have HF? Did we ever figure that out? Yeah, we got HF is 10.9. So we have two lengths that we can figure out. So we could do the Pythagorean's theorem, and we could figure that out. Well, or we could figure out this one. These are complementary angles. So we can do 90 minus 43. This is 47 degrees here. 47 degrees. So that is this angle, or this length right here for this big triangle here. This big triangle, RHF triangle. This is the hypotenuse. This is the adjacent side. This is a 90-degree angle. I'm presuming, no, we can't presume that. This was a 90-degree angle. So we can't really presume that this is a 90-degree angle because it doesn't tell us it's a 90-degree angle. We know that that's a 90-degree angle and that's a 90-degree angle. So, well, that's a 4. Okay, so this is a transversal here, okay, because this is a 90-degree angle, this 90-degree angle. Yeah, so these are parallel lines. So that means that this is a transversal, right? Because these are parallel lines, right? Because that's a parallel. That's a 90-degree angle, and that's 90-degree angle. It means RF and HG are perpendicular. Are parallel. It's making this HF a transversal, if you will, making these alternate interior angles. So this is a 43-degree angle, and this is a 47-degree angle. Okay, so 43, 47 plus 43. So that means that this is indeed, this big angle here is a 90-degree angle. Okay, so that's cool. And so yeah, that's a 90-degree angle. This one here is still congruent to this one here. Let's not lose track of that. Okay. All right. So yeah. So now we can be sure that we can use sine, cosine, tangent, and Pythagorean's theorem on that. Let's do sine, or let's use tangent. Okay. We got 43 opposite. No, we don't have adjacent. We're looking for the adjacent, so that'll work. All right. So the tangent. We'll do the tangent of 43, this one right here, equals opposite 3.4 equals 3.4 plus 4, 3.4 plus 4 over whatever RF is. And that's what we're looking for. We're looking for RF. All right, so RF equals 7.4 divided by the tangent of 43. Tangent of 43 equals, all right, 7.4 divided by 43 tangent equals 8. 7. Oh, that's gonna. Oh yeah, we knew that equaled 8. That equals 8. Should have known that from before. I did that the hard way, right? Yeah, this is like a square. Look at that. That's a square. I should have seen that from far away. All right, yeah, it's a square. Right. 3.4, 3.4, 3.44. It's not quite a square. It's like a rectangle, right? But yeah, these are. I can't believe I didn't see that from before. I did it the hard way. Yeah, so that's 8, right? This is like a rectangle. Anyway, all right. So now we have all the things from the perimeter. So now we can add up. The perimeter equals 4.1 plus 5 plus 4 square root of 2 plus 8 plus 3.4 plus 4 plus 8. Okay, so let's add it all up. Let's do 4. Let's do square root of 2. 2 square root. Let's just start right there and go all the way around. Times 4. Okay, get that one out of the way. Plus 8 plus 4 plus 3.4 plus 8 plus 4.1 plus 5 equals, it's like 38.2. 38.2. Big box so that everybody can see it. Okay, there we go. Let's see. Let me look at the key and see how they did it. They used Pythagorean's theorem to find WM. That's cool. I didn't do it that way. That's all right. All right. What is the total distance if Mario rode from W to H? Where's H? Okay, so W to H, so 5 plus 4 square root of 2, W to Y to H to T. Where's T? Is T the one in the middle? I just destroyed it. Yeah, to T. Okay. Oh, so we gotta figure this one out. So that is gonna be, we gotta figure this one out here. 47. So that's gonna be, so this length, H to T plus HT plus T to X, where's X? Plus T to X. My paper's broke. Plus F to R plus X to R plus X to R plus X to F plus X to F, and then plus F to R. We know that's 8. And then plus R to W, which is 4.1. So we got to figure out H to T. Oh, you can't see what I'm doing. Okay, yeah, you can. Okay. So we got to figure out H to T, T to X, and F to X. All right, let's do that. Like right here. H to T. H to T. All right. So this is going to be a right triangle, and it is that's 47. This is going to be a tangent, opposite over adjacent. All right, so it's going to be H to T equals so the tangent of 47 equals opposite HT over 4. Okay, so HT equals 4 times the tangent of 47 equals the tangent or 47 times the tangent of that times 47. 4 times 4. Right, so this is 4.2. Oh wait, that's the hypotenuse. That's not what we want. Well, that's not what we want. Oops, mistake. All right, this is the hypotenuse that we want. So that's going to be that's the adjacent over hypotenuse. That's a cosine. The cosine. Oh, I should be using purple. The cosine of 47 equals the adjacent, which is 4, over the hypotenuse, which is what we want, which is HT. All right, so the HT equals 4 divided by cosine of 47, which is going to equal 4 divided by 47 cosine equals like 5.9. All right, so I got HT. We now know that is 5.9. All right, TX. T to X. Oh man. All right, so what we need to do here is we really just need to figure out the rest of this. We really just need to figure out this whole length, right? H to F. Right, that's all we really need to do is figure out H to F. We don't need to figure out each one of these little segments, right? Because H to F is just the entire hypotenuse of this one. Right, so we don't need to do each little segment because it's not like he got off of that path, right? I don't think. X to F. No, yeah. So we don't need to do each little segment because this was H to T. T to X. Yeah, we don't need to do that. We just need to do H to F. Yeah, that's better. And we know that 47, we know this angle. We know this angle. We know 47 and we know this angle. So we can do, let's do the sine of 47. So HF. So the sine of 47, that's 74, 47 equals opposite 8 over hypotenuse. We're using this triangle here. Okay? Opposite over hypotenuse. Opposite 8 over hypotenuse. Okay? Over HF. So HF equals 8 over sine of 47. Okay, so 8 divided by 47 sine equals 11. Oh, 10.9. All right, so now it's 10.9. Now I can add all this stuff up. So it's going to be square root of 2 times 4 plus 5 plus 10.9 plus 8 plus 4.1 equals 33.65. 33.65. 33.7 if we're rounding to the nearest tenth. 33.7. Oh my, that was a marathon. Okay. Moving on to the next one. That's not the next one. Let me slide over the book so you can see the next one. All right. All right, Gabby's flying a drone over Lake Jackson. And the drone represented at point H, which is 265 feet above the lake, represented by point B. All right, so this is the lake, and this is the drone. So this is 265 feet. Okay. The angle of depression is angle YHN, and it's 17 degrees. Angle 17 degrees. Okay. Y is YHN congruent to BNH. So this is 17 degrees too. Why are they congruent? Well, this is the horizon, right? And it's perpendicular, it's parallel to this line. How do I know this line here? Okay, these two lines are parallel to each other, right? Because the horizon and and this, for all intents and purposes, are parallel lines. I know there is a curvature of the Earth and everything, but it's so insignificant for these problems that it's you just negate it. Okay, so because these lines are parallel, YH and BN are parallel, line HN is like a transversal. Okay, it effectively is a transversal if it actually extended through the two lines, making YHN and HNB, making those two alternate interior angles of the transversal. Okay, they're alternate interior angles. Okay. And are congruent. Okay. All right. So determine the horizontal distance, BN. So the horizontal distance of this. All right. So this is the opposite over adjacent. So BN, so the tangent of 17, that's the function we need because it's the opposite over adjacent, equals 265 over BN. Okay? Now you can expect it to be larger than 265 when you're done because this is a small angle, right? So anyway, so BN equals 265 divided by the tangent of 17. So we have 265 divided by 17 tangent equals 866.8 tenth equals 866.8. Okay. Determine HN as the hypotenuse. Okay, so we'll use the sine for this. The sine of 17 degrees equals 265 over HN. So again, now it's going to be HN HN equals 265 divided by the sine of 17. 265 divided by 17 sine equals 906.4. Okay, Zach's also flying a drone. His drone is 11,000 feet across the lake. From the fishing pier, the maximum height of his drone is 400 feet. What is the angle of depression Zach should fly his drone so it lands on the fishing pier around here near? Okay, so let's draw a picture. All right, so we got to draw a picture here. We got maximum height is 400 feet. Okay, and it's 11,000 feet across the lake. What is the angle of depression? So we're asking, what is this angle? Right, what is that, or what is this angle? Right, so what is that angle there that we should figure out? Okay, so what do we need to figure out here? We need to figure out the tangent. Okay, the tangent of theta equals opposite 400 divided by 11,000. I left out the units because they're going to cancel out anyway, because sine, you can't see what I'm doing. Sorry. There's my drawing. So yeah, 400 feet high. That's the maximum height. This is 11,000 feet. Here's the little pier. Here's him flying his drone. Here's his drone with some whirring blades. Okay, and then this is the approach angle, the angle of depression that it needs to take to land perfectly on the pier. Okay, it's 11,000 feet away. That's a long way away. It's a couple miles. Anyway, so we need to figure out what angle that should be. All right, so the tangent. So we got to figure out that what is the tangent of theta? All right, so 400 divided by 11 followed by 3 zeros equals, that is the tangent. It's a small tangent. Did I do that right? Yeah. Let's see. 400 divided by 11,000 equals, okay, now I'm going to take the arctangent of that, and so the angle arctangent of that should be, so theta, so theta, I want to solve for theta, equals the arctangent of 400 divided by 1,000. So that equals approximately 2.1. All right, so I'll show you how to do that on a calculator again. All right, so it's 400 divided by 11,000. Right, super small number. Is that right? 400 divided by 11,000. Okay, and then second arctangent. It's the tangent button, but it says negative on the upper right hand corner. and that's the angle of approach. It's 2 degrees, 2.1 degrees. Okay, that's super skinny. Okay. Well, anyway, that was a marathon. 35 minutes of homework. Um, but if you know what you're doing, you're not talking, not explaining, not color coding, probably could have got it done in about 30, maybe 25 minutes. Anyway, if you have any questions with that one, please let me know. I hope you guys have a great day. Please don't be afraid to pair up and do this with friends.